The fall of 2018, I received a call from a long-time customer stating that they are spending way too much money on their data platform and not delivering the best experience for the analytics team.
The voice we're now hearing is Nandan Umarji, and he is here to tell us about how Mactores helped the customer identify the right solution to solving their challenges.
So we set up an ideation session to learn more about his thought process. In that session, we found out that he is expecting data platform to run under $1 million with highly optimized ETL and query performance. Customer had about 2 petabytes of data lake with 2000 data analysts. Their 6 GB of data ingestion was taking 8 to 12 hours to process, and user queries were running for 10 to 20 hours. This was impacting their business and user productivity. It was quite challenging to meet their expectations. One was managing trillions of rows while updating their 1 TB of data in 3 hours every day, and two was to execute big data queries under 20 minutes.
Okay, Nandan, can you tell us more about how they were generating so much data and what was changing for the customer that made solving this challenge a priority?
This customer is a global leader in data storage manufacturing, from common consumer products to enterprise data centers and cloud service providers. They are a vertically integrated manufacturing company. Each factory generates about 5 to 6 terabytes of data per day from the test systems, excluding image data. This data is used both for operational and advanced analytics by various quality, reliability, and product engineering groups.
Great introduction about this customer. Let's also quickly introduce ourselves. My name is Dan Marks with Mactores, and I'm joined by my colleagues Nandan Umarji and Bal Heroor. Nandan and Bal will discuss in details of the solutions to the customer challenge Nandan has shared about their data platform.
Thanks, Dan. When we started working with their analytics team, we used our comprehensive big data assessment process called Hexa Audit. In this audit, we performed an in-depth analysis of the data platform requirements based on few factors, such as end-user tools, long-running queries, security and access control, and storage requirements. I'm going to walk us through Mactores' approach to understand their major challenges and how we solve their high-scale data platform needs within the TCO, which was set by the customer at the beginning of this discussion.
Okay, Bal, so can you outline the findings of this assessment?
Sure. We identified two principal challenges. The first was scalability of their Hadoop clusters to support around 2,000 users and to process 6 terabytes of data ingestion every day. The second was the operational cost of this cluster had to be under $1 million to support their business needs to achieve high ROI.
So based on these challenges you've outlined, can you tell us about the solutions that were identified?
Absolutely. Post our assessment and collaboration with their team, we recommended two broad solutions. One was to migrate their Hadoop cluster to Amazon EMR and modernize their data platform. Second was to build a Spark plus Airflow integrated solution to support a fully automated resilient ETL process.
Okay, really good. So let's hear from Nandan about the customer's feedback on the benefits they've achieved once these solutions were delivered. Nandan?
Customer achieved two major benefits. One, increased operational efficiency as ETL execution time was reduced significantly, improving data update frequency. Two, query performance was enhanced up to 10 times, enabling faster business outcomes. Two, cost savings were achieved due to usage of scale-up and down architecture in Amazon EMR and use of spot instances, providing 70% discount over on-demand price.
Okay, very good. So let's go ahead with you, Nandan, and investigate into the specifics of the challenges, the options, and solutions considered to achieve these business benefits. So my question, Nandan, is what was their core challenge? Can you walk us through the specifics?
Definitely. This is an industry-wide challenge. Customer was using custom Serday in their on-premises data platform to handle absurd scenarios. They faced significant performance issues to ingest billions of records to their dimension tables. A lot of these challenges were due to high IOPS requirements due to their legacy on-premises architecture, which resulted into multiple stability challenges affecting their ETL processing time and performance of end-user queries.
Okay, so Bal, let's turn to you. Now that we understand the challenge, can you walk us through the solution?
Actually, Dan, our engineering team came back with two options. One was to move the data to HDFS. Another was to implement Datalake or Apache Hudi to take care of the absurd scenarios at the storage layer on S3. Since moving to HDFS was an expensive proposition as customer had almost 2 petabytes of data, we recommended them to go with an S3 approach. Now on S3, the two options they had was to use Datalake or Hudi to support absurd scenarios. But the problem was moving to Datalake or Hudi meant they had to change their file format to Parquet. However, the customer team was not so comfortable moving away from their conventional ORC format to Parquet. Thus, we had to look for more options. So we ended up using a custom built solution which was extending the Hive metastore while supporting their existing ORC format. This solution was similar to Apache Hudi, supporting partition by partition absurds to the tables which were on S3 as a storage and supporting the absurd scenarios with billions of rows. This solution resulted in reducing the overall cost at the storage layer, affecting largely on the TCO and ROI parameters set earlier in this discussion.
Well, great. So the core challenge is solved. Now, we had mentioned earlier that there are a few challenges. So Nandan, can you walk us through these next challenges that needed solving?
Sure. Let's talk about how their monolith design was affecting performance and cost.
Okay.
Customer data platform on premises was a single cluster to support ingestion, ETL, and end user queries. Their queries were using TES and MapReduce engines, which significantly impacted both ETL and end user queries. Such monolith architecture was not ideal to leverage cloud scalability and performance offered by Amazon EMR.
Okay, so now Bal, can you tell us how we approach this challenge?
Sure, Dan. Our team investigated their cluster design and came back with multiple options. The top two were to support their ETL through serverless AWS services like AWS Glue and Amazon Athena for end user queries. The second was to use Spark for ETL and Presto for end user queries using Amazon EMR. Now their end user queries were quite massive. When they ran their end user queries, it used to scan about petabytes of data for every query. Now, serverless solutions are less ideal in this scenario as they are charged per TB of data scan. While Presto and Spark, which were running on EMR, could support all of their ETL and end user query requirements while providing them an unlimited data processing capabilities without charging them for per terabyte scan. Once we migrated their query engines to Presto on EMR, the team achieved significantly high query performance, which was up to 5x faster than Spark and 10x faster than MapReduce on Hive, which they were using on premise. While Spark improved their ETL performance quite significantly and reducing the total cost of total processing time to 3 hours from 18 hours to process about 6 terabytes of data every day.
Wow, good. Okay, so we've got two challenges down now. Let's now talk about an industry-wide challenge. Nandan, can you discuss this challenge of schema evolution?
Yes, Dan. Schema evolution is indeed a complex and industry-wide requirement. Most of the manufacturing customers with their dynamic data environment from multiple data sets have to constantly change table structures and data types. This results in performance degradation and increases ETL processing time.
Okay, so Val, what solutions did you and the team come up for this, for the schema evolution challenge?
Yes, schema evolution is indeed a broad topic in data platforms and Hadoop ecosystems. Our team recommended Confluent.io with Kafka and Apache Hudi to be the best out-of-the-box solution. But since customer had some specific data quality requirements, we proposed a custom schema evolution management which was integrated to their Spark ETL framework. To avoid much of the code refactoring to integrate into their ETL process, with metadata changes, customer ended up using custom solution which was built on Spark ETL framework over Confluent.io. Their ingestion process required a dynamic metadata modification to their Hive tables and business logic decisions while managing schema updates, which made all other solutions which were out of the box a bit complicated to integrate.
Okay, great. So we've now covered 3 challenges and 3 solutions. I'm going to turn back to you, Nandan. So what's the last challenge you want to highlight?
Sure. The last challenge was to solve job scheduling and improving ETL execution time. They were using Uzi and had many challenges: data availability checks, inappropriate notification mechanism, and scalability issues with increased data load processes. This meant that they needed a different solution to address this problem.
Absolutely. Scheduling is another important aspect of large-scale data lakes. In our experience, using simple serverless systems takes care of most of the scenarios for scheduling and orchestration. Thus, our team again recommended 2 approaches. One was to use serverless tools like Glue for ETL and step functions for scheduling. Second was to integrate Airflow with Spark ETL to support complex ETL orchestration. Now, as per our assessment, customer had a complex ETL framework, and it was tedious to implement a serverless ETL process like Glue and scheduling systems like step functions. Thus, Airflow was identified as a robust and well-suited solution, which we recommended and implemented for this customer. Airflow can schedule Spark ETL jobs on an EMR cluster using Apache Levi. This API-driven architecture enables Airflow to submit jobs on any authenticated EMR. Thus, we could use transient clusters which were started on demand by Airflow on a scheduled time and stopped after the ETL processing was done. This significantly reduced the ETL operations and the cost of processing 6 terabytes of data every day.
Thanks, Bal. So all these solutions are very thorough. I'm hopeful that you could summarize all of this by walking us through the architecture.
Sure, let's now analyze the entire solution. To solve the problem of monolith design, we separated a single monolith cluster into 3 transient and scalable EMR clusters. These were supporting ETL using Spark and Spark and Presto for end user queries. The queries, which were less than 10 terabytes, were submitted to Presto cluster, while anything which was consuming more than 10 terabytes of memory was submitted to Spark cluster. Now, this was done to avoid unnecessary scaling of Presto cluster because there were only 5% of the jobs which would take 10 terabytes or more memory. The ETL and Spark cluster were configured to utilize auto scaling using spot instances. Spot instances allowed us to reduce the operational cost up to 70%. Further, we also enhanced the data operations of the customer by automating Amazon EMR configuration and deployment by integrating with AWS code commit and code pipeline. Airflow was also integrated with code pipeline to provide updated ETL code to submit Spark jobs through Apache Levi.
Great. So both you and Nandan really outlined the challenges, the approach taken, and solution decisions very well. Thank you. Nandan, though, I have one more request for you. What did the customer think? Could you describe how their business users reacted to the outcome?
Business stakeholders are happy with increased operational efficiencies. Workflows which earlier ran for 12 to 14 hours now are executed in less than 4 hours. Significant improvement in end-to-end ETL processing and onboarding of new tables is improved by 10 times. Analytical queries, which took about 10 to 12 hours to execute, are now executed in less than 20 minutes.
Well, that's great. Thank you both to Nandan and Bal. Thank you for telling us this customer success story and the many insights into the decision-making process used to find the right kind of solutions. And to our audience, Mactores quickly solves core business problems and drives disruptive change by applying the latest automation technologies in data analytics, AI/ML, and DevOps. We design, deploy, integrate, and manage rapid migration and transformation solutions to accelerate enterprise data platform migrations by using automation. To learn more about this customer, we would encourage you to explore these blog links, which go into further details. Blog called Optimize Presto SQL on Amazon EMR to deliver lightning fast query processing. You can find that at mctrs.com/presto. And lower your TCO while gaining 3x the performance on Amazon EMR using Hive on Spark. You can find that at mctrs.com/spark. We would encourage you to please contact us to schedule a complimentary Amazon EMR migration workshop. In the workshop, we will lead your team through a process to define the factors unique to your business and the possible solutions to provide you with a TCO and a path forward. You can register by visiting mctrs.com/HDPAWS. Thank you. Thank you for attending our talk today.